Hi, welcome to Wise Guys. Solving quadratics by completing the square. Before show you how to complete the square, I'd like to have a little bit of review. For example, x plus 3 square. When we expanding this one, we have, actually we can say, because perfect square, we have x plus 3 times x plus 3. And we do for you, we have x times x is x squared, x times 3 equals 3x, and 3 times x have another 3x, and 3 times 3 we got 9. We combine, we got x squared, because 3x plus 3x equals 6x plus 9. So the pattern is when we expand the perfect square, because we have identical binomial, two binomial, that's why these two always the same. As a result, we add together, we have 6x, which is double of 3x. So actually we can write that this one actually is x squared plus 2 times 3x, right? Plus 9. So for this reason, now we need to complete the square, we need to back to this one, right? We're given a trinomial, we need back to this one. So this number is half of this number, is half of this one. 3 is half of 6. But by completing square to solving quadratics is the given trinomial, the given quadratic equation, the constant is not 9, right? So let's try one question. The question is solving quadratic equation x squared plus 6x. For example, we plus 5 equals 0. Solving this equation. Because a perfect square is plus 9, but now plus 5. But these two same. That's why when you're solving quadratic equation using completed square method, first of all, the coefficient of x squared is 1 here. The coefficient x squared is a equal 1. And also, the completing square only related to these two terms. It's not related to constant. So that's why from this review, we can say, we can write this one to x squared plus 2 times 3x, and the 3, we need this one. So then plus 3 squared. But now we plus 5, because we need plus 3 squared to make perfect square. So that's why we can say plus 3 squared, but this is 5, we need to take 4 away, right? Because 3 squared is 9. 9 minus 4 equals 5, which is exactly the question here, see? And write the equal 0. So this is the idea how to, using complete square, the given quadratic equation is not a complete square, it's a perfect square, but we use the first two terms make a perfect square, then by adding or subtraction number to make same constant as given equations. So let's do this. Okay, here. So first of all, we have x squared plus 2 times 3x plus 3 squared minus 4 equals 0. For this part, we make a complete square. For this part, we make a complete square, perfect square, which is x plus 3 squared. And can move the 4, negative 4 to the other side. Say minus 4 equals 0. And we can move to the other side, x plus 3 squared equals 4. So now the left side is a perfect square, right? So now we can do, for solving this one, we just square root both sides. Square root both sides. See, we have square root both sides. But remember, when you square root both sides, you need to put plus and minus. The reason is positive, if this is square root of 4, and the positive 2 square got the 4, and negative 2 square still got the 4. That's why we need to have this. So we have x plus 3 equals positive and then negative 2. And we have two solutions. One, we can say x plus 3 equals positive 2. Then we have move 3 to the other side. We have x equals 2 minus 3, which is negative 1. Another solution, x plus 3 equals negative 2. And moving 3 to the other side become negative 3, so x equals negative 5. So this is the solution, right? This solution. This is the first example. Second example, I'd like to show you 2x squared plus 10x minus 4 equals 0. For solving this quadratic equation, first we find 2, 10, 4, both even number is divided by 2. So we can divide it by 2 for each term here. So we have x squared plus 5x minus 2 equals 0. 0 divided 2 is still 0. At this step, and we start doing completing square. As I said, completing square only related to first two terms. That's why you can see this one is x squared plus 5 is 2 times 5 over 2x, right? See? Because 5 is odd number. So for perfect square, they always 2 times. So we're looking for this. So 2 times 5 over 2 cancel 2 back to 5. But we need this number to make perfect square. And the plus 5 over 2 square but this is negative 2. So for this reason, the first question is easy to figure out. This is a fraction. So we can do this way. We plus 5 over 2 square, we still keep negative 2 here. And equals, we plus 5 over 2 square on the other side. We have 5 over 2 square, right? Because both sides, actually you add 5 over 2 square. It doesn't change the original equation, right? Then we can do, because these three, for this 3, we make perfect square, right? Which is x plus 5 over 2 squared. And the constant we can move to the other side. So we have 5 over 2 squared plus 2. So we have x plus 5 over 2 squared equal, this one is 5 over 2 is 25 over 4 plus 2. We got 2 and 25, 4. So we can make improper fraction. This one we got 4. 2 multiply 8. 2 multiply 4 is 8. 8 plus this one 33, right? 33. So equals 33 over 4. And square root both sides. Square root both sides. Add plus minus in front. So we have x plus 5 over 2. After square root, square cancel with square root, we got x plus 5 over 2 equals positive and negative. So we have, for example, we have positive square root 33 over 4. The 4 can be get out the radical is 33 over 2, because 33 is nothing we can simplify. So we have 33 square root 33 over 2. Then we can solve it. We can move this one 5 over 2 to the other side. So we got x equals, we can move this one to other side, and the both has denominator with 2. We have 2 square root 33 minus 5, right? This is x1. The other solution is x plus 5 over 2 equals negative square root 33 over 2. And move to other side, we have x2 equals 2. This negative square root 33, this move other side, also negative minus 5. So this is presented by Wise Guys. Thank you.